which are page 18, I want to show you something that you might not have seen before, that you might not have realized. If I make up any addition problem, so I'll just do something kind of like 2 plus 9 equals 11, okay? And then another problem, different problem, we'll do 3 plus 5 equals 8. What I want you to see is that you can take these two addition problems, and if you add them together, right, you get another addition problem that is also true. 5 plus 14 is equal to 19, right? Amazing. At least to me, that's pretty amazing. Now, this works for any two addition problems, but it also works if you have negative numbers or if you're subtracting. So, for instance, I could do 5 minus 2 equals 3, and then I could do, I don't know, 11 minus 7 equals 4, right? And we can add these up. And I would do 4 plus 3, okay, that's 7. Negative 2 plus negative 7 is negative 9. And then this is 16. 16 minus 9 equals 7. That's also a true statement. So this works whether the numbers are positive or negative, okay? This is going to come into play later today, but I just want you to see that this works. If you have any two true statements and you add them together, you get another true statement, another true equation. Okay. Now, to get ready for today, we need to be thinking about, this is called the elimination method. So last time we learned substitution and how to solve an equation with substitution. And today we're going to work on a different method. It's also an algebra method. Called the elimination method. And to understand how it works and why it works, I want you to be thinking like, how could I fill in these blanks so that I get 0, so that the variable is eliminated? So if I want to get 0 as the answer here, right, I need the opposite thing here. So I need negative 3x. How do you get 0? 3x plus negative 3x would give me 0. How do I get 0 here? Well, if I have negative 4y, then I have to add 4y. To get 0. If I've got 7x here and I want to get 0 as my answer, I need negative 7x plus 7x. So these are opposites, right? So in order to eliminate the variable, for them to cancel out, they have to be opposites. Okay. Now, sometimes you're going to see terms that are not opposites, but if you want to cancel them out, you've got to think, okay, if I wanted to cancel out these 3x's, what would I have to do to make that happen? Well, one thing I could do is multiply the first one by negative 1. Oopsie, can't really see that. And then this one would be negative 3x. The second one, I'll just bring it over, is 3x. When you add those together, you get 0. Great. Okay. With this next one, same idea. If I wanted to cancel these out, you could multiply either one. It wouldn't actually matter. I chose the second one. This one I'll keep as negative 2x. This one I'll multiply by negative 1, and boom. When you add them, they cancel each other out. And I'm looking at this next one. If I want these to cancel out, how am I going to make that happen? Well, I'm going to have to multiply this one by negative 5. So I would have 5y and negative 5y. Boom. They would cancel out. So we're thinking, how do I eliminate the variable? How do I make them cancel out? What would I have to do here? Well, if I multiplied this by 2, then I would have negative 4y and 4y. They would cancel each other out. What would I have to do down here? I've got 6x and 2x. Well, I could multiply this one by negative 3, 6x and negative 6x. Those would cancel each other out. Now, this next one is a little bit difficult because, like, what do I have to multiply these by so that they're going to cancel each other out? Now, I don't necessarily want to get into decimals and fractions here. So in order to make these two cancel out, one thing that I could do, if I multiplied this one by 5, right, this would be 10y, sorry. Then I would have to multiply this one by negative 2 to get negative 10y, and those would cancel out. Okay, so we're thinking about canceling. Sometimes you have to multiply just one of the numbers or one of the variables, but sometimes you have to multiply both. Okay, 4x and 3x. How am I going to make those cancel? Well, if I multiply this one by 3, that'll be negative 12x. And if I multiply this one by 4, that would be positive 12x, and those will cancel. So the signs have got to be opposite here. So like this one, I really had to think. I had to multiply that by -2. 8y and 4y. That one's not going to be too hard. If I just multiply this by -2, that'll do it. Then I get 8y and -8y, and that's 0. So we're thinking about canceling things out. Okay. With that in mind, and with this in mind, right, that you are allowed to add two equations together and get another true statement here. Let's look at solving a system by elimination, okay? So let me come down here. Now I have the directions here for people who like directions. This says look at the equations, and both equations should be in standard form, which these are. ax plus by equals c, ax plus by equals c. Determine which variable is easy to eliminate when you add the two equations together. So let's look at what we have here, okay? Let's look first at the x's. To eliminate these x's, right, I would have to multiply this one by -3, right? So I would have 3x and -3x. To eliminate the y's, they are already set up to be eliminated, right? If I want to eliminate y's, look at those. I have -2y and +2y. Already set up for elimination. So what I can do now, just like this, right? I have two equations, and I am allowed to add them together. I know that when I add them together, I'm going to get another true equation. So draw a line here. I am adding these two equations together. 3x plus 1x is 4x. -2y plus 2y is 0. Those cancel each other out. 13 plus 7 is 20. Now, this, we could not find an easier to solve equation than this. Divide by 4, x is 5. Okay, now, the rest of this process is just like what we were doing with substitution. Here's what I have so far. I have half of the answer. I gotta find y. I pick the easier equation. So this, we've done step 1, look at the equations and determine which variable will be easy to eliminate. The y will be easy to eliminate it. If needed, multiply one or both equations. We didn't need to do that because they're already matched up to be canceled out. Add the equations together, that's what we did here, and solve for the variable. We did that. And then plug in the value of x or y into either equation and solve for the other variable and write the solution as an ordered pair. Okay, so I go and I look at my two equations. I'm like, well, which one looks easier? I guess the second one looks a little bit easier. X plus 2y equals 7. Let me take this x and put it here. 5 plus 2y equals 7, and then we're going to solve. 2y equals 2, divide by 2, divide by 2, y equals 1. Check by graphing or substituting the ordered pair into each of the original equations. Now, you can, as we did last time, you can take these two equations, you can put them into Desmos, right? You can also check these algebraically, which means I will take the x and I'll plug it in here, and I'll plug the y in here, and make sure I get 13. Okay, 15 minus 2 is 13, yes. And then I have to repeat the process with the other equation. 5 plus 2 times 1 equals 7. 5 plus 2 equals 7. Yes, they both work, therefore I know that's a solution. So that's the algebra way of checking. That's actually faster than probably than taking out your laptop to check on Desmos. Okay. Let's try another one. All right, so first I'm kind of very similar doing an inspection first. I'm thinking first, kind of like identifying the naked variable in the substitution method. I'm looking to see what would be easy to eliminate. So if I look at the x's, this is looking pretty good right now because in order to eliminate the x's, all I would have to do is multiply one of them by -1. So I get -6x and 6x. Over here, that's a lot more work to eliminate the y's. So let's eliminate the x's. Now, this is the tricky part, and this is the part where it's really easy to make a mistake because we just want to like change a sign. It's a little more complicated than that. If I decide that I want to multiply that by -1, you got to multiply the entire equation, every part of it, by negative 1. Okay, so I'm going to get negative 6x, and I recommend writing it over to the right here. Negative 6x minus 10y equals negative 12. I also recommend recopying the other equation right under it because that will prevent mistakes. Okay, now I am allowed to add these two equations together. The whole reason I multiply by negative 1 is so these will cancel out. Negative 10 plus 4 is negative 6y equals 18. Divide by negative 6, y is negative 3. Okay, great. Here's where we are. We have half of the final answer. Okay, you've got half of the final answer. Now we need to go back and figure out what x is. Use either equation, whichever one looks easiest to you. I guess the second one, but it doesn't matter. 6x plus 4y equals 30. This is exactly what we were doing with the substitution method. After you find half of the answer, you got to go get the other piece. 6x plus 4 times negative 3 equals 30. 6x minus 12 equals 30. Add 12 to both sides. 6x equals 42. So x is 7. 7, negative 3. And again, you can go to Desmos to check that. Just plug it in. Just type those two equations into Desmos. So you don't even have to type in this one. Just type in the original ones. All right? Let's take a couple more. I mean, if you're going to ask me, I don't know if you're asking me, but I like this method so much better than substitution. I just think it's more elegant or more fun or something. I don't know. All right, first I'm going to look at variables. I'll look at the x's first. Okay, so what I'm seeing here is 18 and negative 18 and negative 9. Okay, so if I want to cancel those out, I would have to multiply this by negative 2, right? So it would be a positive 18, and those would cancel out. Let's check the y's and see if maybe that'll be easier. No, it won't be any easier because I'd have to multiply both of them in order to cancel those out. So let's work with the x's. I'm going to multiply this second equation by negative 2. And again, if you're going to multiply by negative 2, you must multiply every single piece by negative 2. So this will be 18x plus 16y equals negative 32. Multiply that by negative 2. You got to distribute, and that, and that. The other equation, I'm just going to recopy right on top. And then I can add them together. The whole point is that these were going to cancel out. And now I have 25y equals negative 50. And again, once you get here, it's like it's so easy to solve. Negative 2. Great. Oop, that's a y. Be careful. That's the y value. Pick the equation that looks easier. Second one, I guess. Negative 9x minus 8y equals 16. And now we're going to figure out what x is. So I'll plug in my value of y, which is negative 2. Negative 9x plus 16 equals 16. Negative 9, oopsie, I've got to subtract 16 from both sides. Negative 9x equals 0. Divide by negative 9, divide by negative 9. X is 0. 0, negative 2. And you could confirm that by typing these into Desmos. Okay, last one. All right, so I'm going to look at these, and I'm going to look at the two variables and see what's going to be easy to eliminate. Okay, 2 and 5, well, that's not really easy because you'd have to multiply both of them. Maybe we'll do that. 3 and 5, that's no better. So let's just go ahead and get rid of the x's then. In order to get rid of the x's, I have to think a little bit outside the box here. Okay. I have to get these to be opposites. So if I were to multiply the first one by 5, let's do that first. I would get 10x minus 15y equals negative 20. Okay, Now, in order for them to cancel, this has got to be negative 10x, right? So I'm going to have to multiply this by negative 2, negative 10x, plus 10y equals 40, positive 40, because I'm multiplying negative 2 times every single term. Now, when I add these together, these cancel. That was the whole point. And you get negative 5y equals 20. Divide by negative 5, and you get y equals negative 4. Great. We are halfway done. Maybe a little more than half. Negative 4. Okay, now I got to go figure out x. Use the easier equation. I don't know. First one, 2x minus 3y equals negative 4. This is just like what we did with the substitution method. 2x minus 3 times negative 4 equals negative 4. 2x plus 12 equals negative 4. Subtract 12. X equals negative 8. And you can go to Desmos if you want to check that. I'm just checking it sort of real quick mentally. Negative 16. Yeah. Negative 40. Okay. All right. The next thing that you're going to do is practice these a little bit on your own and hopefully use the paper provided. Okay.